We need to now introduce a few trigonometric concepts. This is the first of a few very quick videos to explain these concepts before we launch into the application in chemistry. This first video will focus on the measurement of angles and the concepts we use for this. You are likely already familiar with one angle measurement using degrees. You're also probably aware that there are 360 degrees in a full rotation, 180 degrees in a straight line, 90 degrees in a right angle, and so on. The use of the number 360 is widely understood to be because that was believed to be the length of the year by ancient Greek mathematicians. It also has the useful property that it has a lot of factors. It is readily divisible by over 20 factors, 24 to be precise, making it easy to slice a pie into different numbers of equally sized pieces, each with an integer angle measurement. As we go through chemistry, and in particular quantum chemistry, we need to use a different measurement. In order to understand this, we're going to need to do some construction. Imagine you've made a pie, a perfectly circular pie of radius r, but now you have a peculiar instruction. You need to slice a piece of pie so that the length of the edge, the arc or the crust, has the same length as the radius. What is the angle which creates this pie slice? Another way of thinking about this is, how many of the pie slices will we get out of one whole pie? It looks like we'll get about 6 of them. But there's a bit of space left over, so the angle can't simply be 360 divided by 6. What we're expecting then is an angle that is slightly less than 60 degrees. Let's then look at the arc length, remember, the crust of our pie, as, after all, this is what determines the number of slices we'll get. Each piece of crust has a length equal to the radius, so how many times can this fit into the total length of the crust around the pie? Most school leavers will know that the circumference of a circle, and hence the length of our crust, can be found by multiplying the radius of our circle by 2 times pi. So whatever the radius of our pie is, we can calculate how long the crust is. Let's now divide this by the length of crust in our original slice. 2 pi r divided by r gives us 2 pi. And this is our answer. We are able to get 2 pi slices of pie out of our pie, or roughly 6.283 slices. Maybe this would have been less confusing if we'd made a cheesecake instead. If we can get 2 pie slices from our now cheesecake, then the angle of each slice must be then 360 divided by 2 pi, approximately 57.3 degrees. This is an angle that we define as 1 radian. It is the angle where the arc length is equal to the radius of the circle and is constant no matter how big the circle gets. This seems a bit odd. Why would we go to use an angle where there is not a whole number of that unit in a circle? It turns out there are a great many things which do not work properly if we don't use radians, chief among which are the trigonometric functions sine, cosine, and tangent. We'll cover these in our next video. Please leave a note in the comments if these videos have been useful to you, or, again, if anything is not clear, and we'll see you next time.